Welcome to this webinar hosted by SDU's Master in Management of Technology. Additive Manufacturing, a technology with more potential. We will try to elaborate on this title during this webinar. The webinar is hosted by University of Southern Denmark, and it's in collaboration with Danish AM Hub. My name is Mette Prask Knudsen. I'm a professor at the Department of Business and Management at SDU. I'm also the center leader for the Center for Integrative Innovation Management. Next to me, you see Henrik Blichfeldt. He's an associate professor at the Department of Technology and Innovation, also at SDU. And later you will meet Steffen Haslund-Schmidt, who's the CTO at Danish AM Hub. If you should, on the way or later, have questions about the Master in Management of Technology, Marianne Harbo Frederiksen is the head of studies, and you can see her email here. You're very welcome to contact her for any questions you may have. This webinar is an introduction, or you can say a teaser to our course in value that is called Value Creation through Additive Manufacturing. The Master in Management of Technology at SDU is a brand new education. We will have the first intake in February 2023. It's a part-time program, and the attendees are supposed to be active in business. The program is really about developing your competences to be able to strategically lead the development and the commercialization of new technologies. It's about understanding the strategic interplay between technologies, market, and business development. And in that way, you will learn to avoid pitfalls and see how to exploit opportunities. But you can have more information about the program on this website. So let's go to the topic of today. What is the webinar about? We will try to introduce to you what is additive manufacturing or 3D print. What is it? How it works? And what are the challenges? We will talk about the importance of connecting technology with value creation, whether it's for innovation, efficiency, or sustainability. And we will give you examples on the way. Additive manufacturing is a technology that allows you to create things or products layer by layer. There is a digital design, and through the digital design, you're able to produce with just the necessary materials. That means also minimizing waste. There is no use of any tools in the process, so you simply have the design and the technology. To illustrate this, we will show you a first video.
Newsec og Newsec Engineering er en fynsk virksomhed, der laver optiske sorteringsmaskiner og pakke- og vejmaskiner hovedsageligt til grønt og frugt. Og i Newsec Engineering, som jeg er en del af, der sidder vi en stor udviklingsafdeling, der laver en masse forskellige udvikling inden for forskellige kamerateknologier, hvor det her projekt har været en af de kameraer. Så det komponent, vi hovedsageligt har optimeret i det her forløb, det er selve den gitterstruktur, der ligesom holder alle de optiske komponenter i det her kamera, som vi gerne vil smide op på en drone. Udfordringen med det gamle komponenter, og egentlig alle iterationer siden da, har hovedsageligt været det her med at holde alle tingene fast, uanset hvilken orientering kameraet nogle gange står i. Og især rotation er ret vigtig i det her tilfælde, og det har været svært at ligesom designe noget, der er præcis nok til at holde det hele fast, samtidig med, at det også er rigidt, og det er let at flytte rundt på og teste. Så de hovedsagelige gevinster ved det her 3D-print, det har især været i forhold til vægten, hvor det er blevet markant lettere, end det var tidligere, på grund af, at vi nu kan bruge titanium i stedet for plastik. Så styrken er også markant bedre af samme grund, og til sidst er selve økonomien i det også bedre, i det vi ikke skulle have specielt fremstillet et komponent, som har nok styrke til at holde konstruktionen. Vi ser et ret stort potentiale i 3D-print, mere og mere faktisk, og i takt med, at vi køber også flere og flere printer, fordi vi hurtigt finder ud af, at vi kan lave komponenter meget hurtigere og lave mange flere prototyper. Også i forhold til pris er det ret relevant, at komponenter, som bliver brugt i de forskellige maskiner, egentlig kan laves meget, meget billigere på f.eks. en resinprinter, end de kan, hvis de skal ud og bestilles udefra og laves i plast. Men især den her prototyp-del for mig og også i udviklingsafdelingen er ret relevant, fordi man hurtigt kan komme igennem forskellige iterationer og spare en masse tid, i stedet for at skulle sidde og modellere og simulere det hele.
Yes, interesting case and definitely exciting to meet people who can really see the potential in 3D printing. And it is easy. It is about getting an idea, having the 3D CAD drawing, then you have a printer, then you push the button, and then yes, maybe you have a component. So yes, it is easy, but there is more to it than so, and that's also what we will try to elaborate on here. So there are some steps in order to decide what to both what, but also how to do additive manufacturing. There's first of all the technology choice of either having subtractive or additive technology used. Then you need to think about the concept. What are the domains we're in? And then again, which application areas are there? When we have that, we also need to go into the triangle of technology choice, design choice, and material choice that are to quite an extent interrelated, but we will come back to that. First of all, talking about 3D printing or 3D print, that is the overall technology. Then we can move a step down where there are different concepts, either R&D, research development, manufacturing, or maintenance. Below that, we can see in R&D, we go for rapid prototyping, and that can be all kinds of prototypes used for testing. And that can both be for field test or others. Then when we move to what at least I pronounce as additive manufacturing, we have direct tooling and direct manufacturing, where direct tooling is more tools supporting the existing production, going for example, flexibility, where direct manufacturing is finished products, components, spare parts, and the like. And then we also have a track on maintenance, which is more direct repair through printing. So we have, through the last 3 years, made some screening of the Danish industry and the use of additive manufacturing. And we can see that the majority, and that is the large circle, almost 70%, are actually not using additive manufacturing or 3D printing at all. And then we can see there are some divisions on how much they use it, but you can either buy your services, you can either have your own printer in-house or lease it, and then you can also have a dual strategy where you both have your own printer and have competences, but also utilize print services outside. And what are they actually using 3D print for? And we can see that the motivation is definitely speed, and speed is within especially prototyping. We can see most of the elements here that are visual. You can see the both the length and how different the lines are, has something to do about how important it is and how much it has changed in the 3 surveys we see. But at least fast prototyping, fast validation of products, and also development of new products has a significance in the motivation in the companies. So what is it that is important when we talk about 3D printing? At least you can identify 3 axes. You can talk about complexity, you can talk about customization, and also volume. And just to give a couple of examples, we have components that are that complex that traditional manufacturing are not able to do it. Symbolized with number 3. Symbolized with number 5 is the customized for individuals. I've shown the hearing aids that could be a jaws, tooth, and other kind of things directly for the human being and the body. And then you can also have manufacturing of the few things that you only do once. Here, for example, 3D printing or additive manufacturing will actually make okay sense. But we talked about, we have technology, we have design, and we also have material. And they are highly interconnected, and we'll go through that now. But it will really require a new mindset, and also a relatively structured approach in how to come from a strategic wish to an actual print. So, for example, technologies-wise, there are within 3D printing, there are multiple technologies that are actually significantly different, and especially within materials, the filament, the powder, the resin, etc. You also have different design options linked to different technologies, and you also actually need different skills and setup even within, for example, SLA or SLS, because you can go for even desktop versions to more industrial versions. So there is a huge span within the technology, but there is a technology for every purpose. In relation to the design, especially as you see in the graph in the middle, we can see that there are something that goes beyond traditional manufacturing. And this is actually trespassing the impossible, because as you can see in some of the pictures, through design for additive, generative design will really push the complexity and the customization, where we also have a higher value. And then finally, materials will also be dependent on the technology, but again, also linked to the design. And we have, in the start, in the 80s, with 3D printing, you only have a few. We have multiple now within polymers, metals, ceramics, and so on. And actually, especially interesting within composites and reinforced materials, so you can really gain some good material characteristics, strength, durability, and so on. And just highlighted a few in the bottom, where you see you can also print concrete, so you can actually build houses today. You can actually even print human tissue that can work with your body, and even print in wood. So materials are constantly expanding. So when we look at this, then it's a matter of actually building the business based on these three elements. And you could ask, can everything be printed properly? Should everything be printed? From my point of view, no. Will 3D printing or additive manufacturing make it different? It will definitely, and also a big one. But it requires a more structured, a more strategic approach on how to do 3D printing in a corporate and a business to unfold the business potential. And I brought an example to discuss some of the challenges that we have here. On the right, Heidak has been kind to share the case. It's actually quite an old case, but it's a hydraulic box where you pump with high pressure oil through. And they really saw that going from innovation to a prototype to the final product really made it much faster and easier for them inside the organization. They also saw that because they didn't have to make these very expensive prototypes that also took a long time, there was much higher willingness of taking risks and chances in the development phase. So that was very positive. But it also takes time to get these benefits. So it's also something about getting domain knowledge. When they tested this, they was printed in titanium, you see, and it has both been optimized in the internal flow, but also in weight, and then printed in titanium, extremely expensive. And when it was tested, it was actually not, the material structure could not hold the high pressure. But this is an old case, and technology and the material matures all the time. So it's also important to understand that on the prototype, you will maybe use one technology and one material, and moving on to the product itself, you will change also maybe even material and technology, and even add post processes. So finding the business case, the potential of value creation is extremely important. And now Steffen from AM Hub will take you on to a more strategic perspective.
Thanks, Henrik. Thanks for having me. Yeah, it's really interesting, and we have had a good introduction to the more technical parts of it. I would like to focus a little bit and take a higher view on stuff, and try to elaborate on why this is a business perspective too. We have put 3D printing AM in 4 boxes here. It's all 3D printing. But if you look at the graph, if you go vertical, we change the complexity of the product, how much it's specialized for 3D printing. And if you look at the horizontal axis, it's the change from no changes in the production setup to a highly automated or highly 3D printed setup. So let's start by focusing on the lower left part. That's the low-hanging fruits. That's where you can easily change from a existing machine part to a 3D printed part. For instance, as Henrik has told, in production setups, in tooling, in fixtures, that's really an easy way of getting into 3D printing, bringing the technology into the business. You can also do spare parts. There's even companies like Demanix from the Netherlands that has specialized in digitizing inventories of companies and offering them to be the supplier on demand for spare parts or for tooling parts directly. So you don't have to spend square meters in your factory on spare parts. If you're moving up to the upper left corner, that's where we look at the product itself, the part itself, trying to optimize it for additive manufacturing. It's really important to know that if you optimize a product, if you remove materials not wanted, if you optimize the function, if you combine objects into one, you will have much more value from your AM, from 3D printing. We call it design for additive manufacturing. You can use computer-assisted optimizations, like topology optimizations, like generative designs that help you optimize a product. And at the end, you will end up with a part or a product that cannot be made in traditional ways, and thus making it much more valuable. And additive manufacturing is the thing to use. If we go to the right instead, in the lower right corner, that is where we don't change the product itself very much, but we change the way we produce it. Look at it in this way. Let's say that traditionally you have injection molded parts from a Far East company. Everybody has known for the last years that the supply chain can be vulnerable. If you use additive manufacturing, if you use 3D printing, you can bring your 3D printing, you could bring your production closer to your customers. And that is a really interesting thing. And it's happening right now. Companies like, we have a Danish company called Undertech, who has this print farm with hundreds of 3D printers standing in line, being able to produce. And why do we make farms? Because it's a slow process. 3D printing can take maybe 2 hours for a part, which you can mold in 15 seconds in an injection molding tool. But if you produce in parallel, you are able to get to the same amount of parts in the same time, just without spending money and time on tools. The last quadrant up in the right corner, that's where everything really takes off. That is where your product is, how can I say, uses all the benefits of AM, and your production and your supply chain also uses all the good sides of AM, of 3D printing. That could be, we have a good example, Philips Lighting, a big company creating light sources. They have seen the specialty in 3D printing lamps from circular materials locally close to their customer. And in that way, they can offer a totally optimized product to that specific customer. And this is definitely something that is going to be very interesting. This picture is from a Danish company, Created Real, who developed a shoe insole making system. And I say system because it's a combination of both measurements, mathematical calculation, and 3D printing as a complete package that could really benefit the orthopedic shoemakers and making their lives much easier, and the customer will have a better product. So there was kind of all the way around the ways that 3D printing can make an impact on your company, less technology wise. Another example here is from the Danish company Monocool. They make eyewear, and they were at hard times. They were usually having their frames for their glasses produced in Far East. Their tools for the molds were also produced in Far East, and they had a very, very long line in their supply chain. By changing 180 degrees and using 3D printing as a manufacturing means, they could cut their process, they could cut their development times, and they're able to develop new eyewear in a couple of months instead of in half or one entire year. So that really makes a difference for them. And yes, if you compare the basic cost of a 3D printed eyewear frame with an injection molded eyewear frame, the 3D printed part will always be more expensive. But taking all in consideration, tooling cost, waiting time, agility, then it's very clear that additive manufacturing is a much more agile way of producing and will be at the end a cheaper alternative if your market is requiring that type of few but a large amount of variance. So at the end here, I would like to show you a short movie. It's from Tons. It's a Danish company that is creating accessories for indoor cycling. And he started as out of curiosity, but made a business based on 3D printing.
Tons laver standard til indendørs cykling. Det vil sige, når du cykler indendørs, så har du brug for en iPad eller en computer eller tv foran dig. Og det laver vi. Vi 3D-printer i nogle miljøvenlige materialer, bioplast, og så bruger vi europæisk, primært dansk egetræ. Tons startede som, det var egentlig bare et hobbyprojekt. Jeg lavede sådan en standard til mig selv, og jeg ville egentlig bare teste ideen om, kan du bruge 3D som produktionsmetode og sælge det direkte til forbrugere. Det var bare et testwebsite, som stak fuldstændig af. For os er 3D-print en kæmpe fordel, fordi det giver en masse fleksibilitet, og det har meget lave opstartsomkostninger. Så de to ting forenet gør, at man kan rykke ret hurtigt på nogle ting, og man kan tage nogle ret store chancer i forhold til, hvad man kan med normal produktion. Så hele det der meget enkle setup, hvor du kan gøre det hele fra idé til markedet på kort tid og med få processer, giver en kæmpe fleksibilitet. Det reducerer kompleksiteten, hvilket den anden ende giver en stor innovationsgrad. Det her handler om, at man skal designe med den æstetik, der er. Altså, du styrker den æstetik, der er i 3D-print. Så ligger den sådan en lille smule mellem sådan håndværk og sådan noget industriproduktion. Og det har, altså i hvert fald min kundegruppe har taget voldsomt positivt imod det. Meget bedre, end jeg havde regnet med. Jamen, næste skridt, det er at udbrede produktionen lidt. Altså, drømmen er lidt at lave nogle små container units, sådan solar-powered 3D-print container units, og kan placere dem, hvor der er behov for det. Så man kan bevare sin miljøvenlige profil, men også give en bedre service til brugere, så de kan få shippet deres ting hurtigt og på en kort distance.
So now you've heard about the choices, you've heard about some of the challenges, you've heard examples. And just to wrap up before we move on to the more practical side, some of the benefits that we have introduced you to relate to the speed. Speed in terms of having a faster prototype available to discuss, make changes to. Quality, the quality that you can deliver to your customers, as Tons' example just showed you, but also quality in terms of different abilities of the product, and flexibility, changing between technologies, but also changing in terms of your setup. And of course, this all relates to innovation. You've heard that it relates to sustainability, and it certainly relates to customer needs, being able to meet the customer exactly where that particular customer is and what he or she requires. So who is the course target participant for this course? Well, it can be anything from a senior manager to an assistant. It can be anything from someone working directly with technology, in operations, in R&D, or in innovation and sustainability. The course is developed in such a way that it doesn't matter whether you have 3D print experience, nor is it a disqualifier if you know nothing at all. So everyone can participate and get something out of it. That's the way we designed it. Value creation through additive manufacturing will take place in March and April 2023 for the first time. It will be repeated later on, of course, but that will be our first time. It's 2 days, 2 single days. There will be some homework between these 2 days where you can actually test some of these tools in your own organization. At least start thinking about it. There will be at the end a take-home exam and how to develop a strategy for using or increasing the use of additive manufacturing.